Let's jump right into this explainer. Today, we're breaking down a super fascinating analysis from this Silverzz channel that explores the hidden physical requirements of our rapidly expanding digital world. We spend so much of our time marveling at the cloud, software updates, and the honestly mind-blowing potential of artificial intelligence. But as it turns out, our virtual world, it has a very physical and very shiny anchor holding the whole shebang together. So what exactly connects artificial intelligence to precious metals? It feels like a total paradox, right? We usually think of AI as just millions of lines of code, complex algorithms, abstract thoughts floating somewhere in the digital ether. But how does something so abstract fundamentally rely on a tangible, physical commodity that literally has to be painstakingly mined from the earth? Well, to figure out this hidden connection, we've got to look at where artificial intelligence actually lives and breathes.
The contrast in scale here is absolutely wild. On one side, you have the standard requirements of traditional data centers. These are the conventional server farms we've relied on for years to, host websites, stream movies, and store emails. They're big, sure, but their operations are pretty predictable. But then, on the other side, you have the massive exponential processing needs of modern AI data centers. AI doesn't just store data, it trains on it, constantly. It computes complex models using billions of parameters simultaneously. This takes vastly more energy and raw processing power than anything we've ever built before. We aren't just building bigger warehouses for AI, we're building entirely different beasts that run incredibly hot and demand an unimaginable amount of electricity.
And when you zoom in from that massive warehouse scale down into the actual guts of an AI data center, you get a really fascinating hardware breakdown. Basically, you've got these highly specialized servers taking up half the demand, high-speed network switches connecting them at lightning speeds, and of course, massive cooling systems required just to keep the whole thing from melting down. Every single piece of this equipment requires specialized, high-grade materials to handle the extreme electrical loads. The servers and switches are literally the physical muscles making AI possible, and they are incredibly hungry for materials that can actually keep up with their blistering pace. Zooming in even closer, peering microscopically into the advanced circuitry powering those AI servers, we hit a literal physical wall, the circuitry bottleneck. When you're pushing that much electricity through tiny microchips to process advanced AI algorithms, you generate intense friction and massive amounts of heat. Think of it like trying to push a fire hose amount of water through a tiny standard garden hose. The pressure is just astronomical. Standard materials, like the typical copper or aluminum wiring used in your everyday electronics, they simply cannot handle the heat and energy transfer required at this extreme density. If you use standard materials in these high-end chips, they will literally burn out, or they'll lose massive amounts of data efficiency because of electrical resistance. Basically, the hardware just physically cannot keep up with the software.
So, the solution to this bottleneck? It comes down to the undeniable laws of physics. Silver. Silver possesses entirely unique electrical and thermal conductivity properties. Actually, it is the most electrically conductive of all the metals on the periodic table. And, bonus, it's also the best thermal conductor. This unmatched ability to move massive amounts of electricity with the absolute minimum of resistance, while simultaneously pulling intense heat away from the chips, makes it the absolute non-negotiable solution for these cutting-edge components. When tech companies are building multi-million-dollar AI server racks, they cannot compromise on efficiency. Silver isn't just a luxury here, it's a physical necessity to keep the AI revolution running without, literally catching fire. Now, to make this digital future a reality, the sheer volume of physical material required is just staggering. The Silverzz channel highlighted a really eye-opening metric. We are talking about well over 10 million ounces of physical silver demanded by the tech and AI sectors annually. 10 million. And that number is actively skyrocketing. The digital boom we read about every single day translates directly into this massive metric of raw silver consumption. Every new iteration of an AI model, every new mega data center constructed, every leap in processing speed, it all adds a huge multiplier to the physical tonnage required to actually build it. This whole dynamic is perfectly captured by a central takeaway from the Silverzz channel. The invisible backbone of the AI boom isn't made of code, it's buried underground. Think about that for a second. While the whole world watches the software, marvels at the newest algorithms, and closely tracks tech stocks, the physical supply chain is quietly bearing the heavy load. The silver has to be discovered, dug up, refined, and then precision manufactured into the microscopic pathways that actually allow artificial intelligence to think. And when we project this trend into the future, we're essentially looking at two colliding trajectories. On one hand, you have the endless exponential expansion of AI algorithms. Tech companies are planning to double, triple, or even quadruple their computing power in just the next few years. But on the other hand, you have the very finite, earthly supply of mined silver. You can't just write a new line of code to generate more physical silver in the ground. Mining is a really hard-to-scale reality. It takes over a decade, massive capital investment, and intense labor just to bring a new mine online. So we're watching this reality unfold where one trajectory is shooting straight up into the infinite digital clouds, while the other remains firmly stuck in the slow geological reality of our planet. As we wrap up this explainer, I really want to leave you with this final provocative thought. Can the digital revolution survive without the silver to power it? It's a serious question, and one we rarely consider when we're busy marveling at the latest AI chatbot or instant image generator. As artificial intelligence continues its aggressive, unrelenting expansion across literally every single sector of our global economy, will this precious metal, an element forged in ancient supernovas and painstakingly extracted from the dirt, ultimately dictate the physical limits of our digital future? It is a profound bottleneck to consider, and honestly, once you see it, it completely changes how you view the AI arms race. Thanks so much for joining me, and keep exploring the fascinating foundations of our world.